Okay, we had some technical difficulties. To save time, I don't have time to go back and start the whole thing over, so I'm just going to pick up sort of where it kicked off. We were going over methane, and it was talking about how carbon is the most electronegative, and hydrogen would then be at the mercy of carbon. So if that's the case, hydrogen is not the most electronegative. It's +1 out of its two options. So there, x plus 4 times -1 equals 0. Carbon has to be, -4. That's what I get. All right, moving on to number 8. In this case, oxygen is still the boss. However, potassium in its own way is the boss because it is an alkali metal. And it only has one rule. Alkali metals have to be +1. No conversation about it, they have to be. Since there's no one challenging oxygen supremacy and electronegativity, it will still be -2 as part of the polyatomic ion. What we don't know is the chlorine. Now chlorine can be anything from -1 to +7. This is perchlorate. Anything with a per is +7. But let's do the math. We have 1 for potassium, we have X for chlorine, and then we have 4 -2's for oxygen. All that equals 0. 1 plus X minus 8 equals 0. X equals +7. So this chlorine is indeed +7. Number 9, we have carbon disulfide. Here, even though their electronegativities are very close, sulfur is considered the non-metal, the bigger one. It is -2. So carbon is going to be X. X plus 2 minus 2 equals 0. X equals +4. So sulfur is -2. Carbon +4. Don't let number 10 fool you. Number 10 looks easy. However, lithium has to be +1 as an alkali metal. In this case, X for oxygen plus the +1 equals 0. X equals -1. In this case, oxygen is only -1. It's peroxide. All right, moving on to number 11, we have cadmium nitrate. In this case, oxygen is still the most electronegative, -2. I think it's easier to take this one. You could bring it out to the side and say NO3 -1, and then solve for X for nitrogen. Or, knowing that it's nitrate, again, ends in ATE, nitrogen has to be +5. Now we could turn our X to cadmium and solve for X. But I know that nitrate is -1, and there are 2 of them. So that's going to give me a grand total of -2 charge. So this cadmium has to be equal and opposite, +2. So I could do that one without any math at all. Moving on to number 12, we have an alkaline earth metal. So while oxygen is still the boss, calcium has an overriding rule. It has to be +2. So this OH negative is hydroxide, polyatomic ion, where oxygen is still the boss and does happen to still be -2. That -2, however, forces the hydrogen to move into its positive version, so +1. Again, no math required. In number 13, I have 2 nonmetals. So when that's the case, your less electronegative one can be anything from its lowest possible oxidation state, in this case -2, to its max, +6. So the most electronegative is iodine, and when a halogen is the most electronegative, it will be -1. So let's find out what sulfur is going to be. We have X plus 6 times -1. This time it's going to equal -2 because we have a charge. X minus 6 equals -2. Therefore, X equals +4 for sulfur. Not an ideal state for sulfur, but one it can exist in. And then finally, number 14, we have bicarbonate, also known as hydrogen carbonate. When you put hydrogen in front of a polyatomic ion, you are saying that it is in the +1 version. Oxygen is still the most electronegative and will be -2. And again, recognize this as carbonate, ATE. That means carbon with its 4 valence is going to be maxed out. +4. Okay, so if you need more practice on oxidation numbers, come by and see me and we'll come up with something. Or if you can think of an example that maybe I haven't addressed here going over this, bring it to my attention, bring it to the class's attention, let us know, and we'll do it in front of everybody. Otherwise, let me know if you need any help.